In this problem, we're given a quadratic function, and we are asked to solve the equation f of x equals -7. Because you may not be used to seeing equations in this format, let me show you what that means. If the equation we're going to solve is f of x equals 7, what that really means, since f of x is equal to all of this stuff, we're trying to find when all that stuff is equal to 7. So you either replace all of this in the place of f of x, or maybe the easier way would be to replace f of x with 7. So since f of x is equal to 7, I can take that notation and simply replace it with the number 7. And that makes this equation look a lot more like you're used to. So here is my equation I'm going to solve. If you read the directions, we're allowed to use our graphing calculator. So it says solve using your graphing calculator. Then eventually we will show the solutions on the graph on the computer down here. So I'm going to immediately go to my graphing calculator. And when you turn your calculator on, you automatically start at the home screen. Go to the y equals to type equations in. If you have equations already, you can hit clear. I'm going to go down and clear this one out. So my first equation would be either the left-hand side or the right-hand side, does not matter. I'll type the 7 in first. Down arrow, and my second equation is going to be x squared. Subtract, it doesn't like me. There we go. Now it did it twice. Beautiful. Subtract 10x, and then plus 13. So now I have both sides of my equation as two separate equations in my graphing calculator. If you graph it on the standard window, it probably would show up, but I'm going to use the recommended settings right here. So go to Window and change your x-min to -5. So let's say that you start on a standard window and it said -10. You don't need to delete it. You can actually just type over it by saying -5. Well, not saying it, but typing it. And then go down to your x max. Again, you could either clear it out, delete it, but sometimes I like to just type over it. If I want my x max to be 13, I'll just type in 13. And then down to my y min, I'm going to type over whatever's there with -17. And then go down to your y max, and it's supposed to be 5. The default is 10, and if it says 10, you can delete it by just typing in 5. And typically, you can just type over it without using the delete key. At any rate, you hit graph, and you get a graph of y equals -7, which should be a horizontal line down here. And the other thing we typed in was the parabola here. So the question is, why are we not seeing y equals -7? I'm thinking I typed in +7 by mistake. So go back here, and indeed I did. The output was not supposed to be 7. It was supposed to be -7. So fix that mistake. Go back and type in -7 and graph it. So here we go. We've got a horizontal line through -7. And here's the parabola. And we are allowed to use our intersect feature. And it turns out the intersect feature only finds one intersection at a time. So you're actually going to have to use the intersect feature twice. This is how it goes. The intersect feature is found by pressing second trace. And it's there, number 5 is the intersect feature. And the calculator doesn't know how many curves you have. It assumes you might have many. So it asks, is this the first curve you want me to consider? You say yes by pressing enter. It pops to the second one. It says, is this the second curve you want me to consider? You say yes by pressing enter. Now it says guess. You can actually just press enter, and it'll probably find the one on the left because it's closer to where your guess is. But if you wanted to guarantee you get the one on the left, you could trace over to the left, but just realize that you're still just guessing. This is not the intersection. You need to press enter and enter your guess and make sure it says intersection. And I think eventually you want us to round to 2 decimal places. You actually have to go down to the bottom of the problem to see that. Somewhere in there, it doesn't say. Where does it say how to round? I know in the other problem it says, there it is right here, round to 2 decimal places. So we are to write the solutions as a list of ordered pairs, but round the values of x to 2 decimals. So when I type this in, my answer is 2.763. 2.763 to 2 decimals. Since this number is below 5, I'm going to leave this 2.76. So the intersection would be 2.76, comma, and then all the y values on that other equation was -7, so I'm sure it's 7. So we'll type these coordinates in. And then might as well, before I do that, just find the other intersection while I'm at it. So go back to second, trace, select option 5 again, press enter twice for is this the first curve, is this the second curve? But this time on your guess, if you press enter now, then you're going to get the same answer again. You don't want that. And this is the time you're going to want to right arrow over. I've seen a lot of students right arrow over at the beginning, knowing they're going to have to do that, and the calculator does nothing more than pop them all the way back to the left, and they wasted their time and have to retrace anyway. So wait till the guess before you trace over. This is not the answer, it's just you guessing. Press enter to get the answer, and the intersection is roughly 7.236. 7.236. Rounded to 2 decimal places because this number is 5 or higher. We are going to round that to a 4. So 7.24 comma -7 would be my other point of intersection. So I need to type them in. I know you know how to do that, but I'll just do it quickly. It was 2.76 comma -7 was the first one, and then put a comma between your 2 points, and then the second one was 7.24, and then y value was -7. So I've done that part. I've wrote the points of intersection as ordered pairs. So I've done everything I'm supposed to so far up to problem 1. Even tells me how to write my answers here. We had 2 answers, so you write them exactly how I did, just like this. Then it says to use the line tool. We're going to try to emulate what happened on the calculator. Use the line tool to draw the horizontal line y equals -7. So go down here. We're already on the line tool. You can click on it. The horizontal line -7 was a line that went through -7 like this. If you were to click and hold the mouse key down on any point whose y value is -7, move either left or right to pick another point whose y value is -7, let go, you have yourself the graph of y equals -7. Do not ask me why I'm so enthused about this. Anyway, that was problem 2, or part 2 anyway. Part 3 says use the polynomial tool. That is this guy down here. Click the polynomial tool, follow the directions. It says do that by using the vertex. You'll need to find the vertex and one other point. So we have 2 other points already, so you could use any of these 2 as your other point. You know, I don't really care which you use, but what we need now is the vertex. So I could show you on the calculator how to use the min feature on the vertex, but I think I'm going to use -b/2a because the numbers are so simple. So the vertex is, of course, an xy pair, but the x value of the vertex, whatever the variable is for the input, it can always be found by doing -b divided by 2a. So if you go back, in general, a quadratic is ax squared plus bx plus c. It's having a little bit of trouble keeping up with me. So in our case, what's our a and our b? So in our case, wrong one. Our a is 1, and our b is -10. So a is 1, and b is -10. Not sure I really like green today. So I'm going to put those in there. So we are to take the opposite of b. Our b is -10, so we're supposed to take the opposite of that. The opposite of -10 would be +10, and then divided by 2 times a, and in our case a is 1. So we basically have 10 divided by 2 is 5. So that always gives you the x coordinate of the vertex. How do you find the y, you ask? The y value you simply plug back into the equation. So if you look at the equation here, the parabola, you'd simply replace x with 5 here, replace x with 5 here. This is actually easier just to do in the calculator since we've already done the work. If you go to graph and you hit trace and get some x values down there, now I'm on the line y equals 7. You can see it right there. So if you press up or down, you want to be on the parabola. You can now, since you already have some x and y showing up, since you've already pressed trace, I guess pressing trace, I have to go back up now. You can just type in 5, enter, and it'll do the arithmetic for you. If you plug in 5, you get out -12, and it sure does look like that's my vertex. So 5 comma -12 is the vertex. So I now have my vertex, and I certainly have another point there. So if you wanted to have done that by hand, you could have done that. You could have taken x squared minus 10x plus 13 and taken the time to plug in 5, and that would be 5 squared minus 10 times 5. plus 13. Do the arithmetic on that if you'd like to do it that way and verify that you indeed still get negative 12. So remember, this is my vertex, 5, negative 12. So going back, you may have forgotten what we're supposed to do. Use the polynomial tool. The polynomial tool is this. You graph it by using the vertex and one other point. Our vertex was 5, negative 12. That's down here. So this is the point 5, negative 12. I click and hold down. And then as my second point, you could either use the 7.24, which is about right here. And it he has the snap to grid feature. So, this to me does not look like 7.24. It looks like 7.5. So you'd want to bounce over a little bit more. And that must be the 7.24 comma negative 7. That would be another point. Or you could have used the 2.76, which is over here just to the left of x equals 3. So here's x equals 3. If I was to move over slightly, 1 over, it would snap to the grid, and that would be my 2.76 comma negative 7. Either way, you get the graph of the quadratic, and we are almost done. We are on step 4. Use the point tool, the last feature down here. Click on the point tool, and it says to plot what? Identify the solutions. The solutions were the intersections here. One was 2.27 comma negative 7, so click there. And the other one was 7.24 comma negative 7, which is right there. And you notice that the points are nice and round and bigger than these squares, showing that we used the point tool there to get that.